Hey, happy Memorial Day everyone. 2017 here, having fun. Part 7 in the single-ended amplifier series. Hopefully we'll wrap this thing up in maybe 10 or 11 videos. I know it's a long series and you know, a lot of people like the short videos, but if I'm going to do it, I'm going to do it right, and hopefully you appreciate the length of some of these and the depth we go into. But anyway, today we're going to dive right on into the power supply build for this thing. We're going to actually do it here on the bench, and I think we've walked you through this before, but a quick overview. Basically, you've got 120 volts here on the input. You got a power switch here, fuse, a couple capacitors across the switches here to just keep the transient surge down a little bit. Got a fuse, then you got the primary winding of your transformer. Transformer then here, you know, has secondaries here at 6.3 volts with a center tap, which we'll use actually to feed the heaters. And if you remember, we're pulling this over here, doing this little drop down and floating the voltage with some DC offset in the neighborhood of 70 to 80 volts. But at any rate, 6.3 volts center tap, 4 or 5 amps. We're also going to have to pull off here and feed the cathodes of these the plates of these two tubes here on pins 4 and 6 of a 5U4, as well as we're going to have to get 5 volts off of another winding here to actually feed the heater, and in this case it will actually be this directly heated tube, so the heater is the cathodes, pin 2 and 8. Which will ultimately then end up creating about 450 volts or so right around here of DC unfiltered at this point coming off of this rectifier. And then between this series of capacitors, inductors, capacitors, kind of CLC filtering here, you actually end up starting to smooth that out pretty smoothly. And so you'll have 450 volts here. Then you do a drop down resistor on both legs. Remember, we're splitting the rails here, one for left channel, one for right channel. Through an 8.2K ohm resistor, we'll drop down to 350 volts, and again we'll pull that across a, so then this becomes a CRC filter here. And we use 22 microfarad to help smooth out the voltage even a little more here. And we end up with 350 volts to feed the input tubes, as well as then drop down with a 10K and get another CRC. And we end up with 300 volts left at that point to feed the, I believe this actually feeds the, this feeds the SRRP section, the 350 volts here, and the 300 volts feeds the very first 2 preamp. That's really all there is to the power supply. Let's take a look here how we're going to go about building that. Got a board laid out. Let me zoom out a little bit here. Just a board. This is where the breadboard comes from. So we've got a socket here. This is a socket actually for a 807. We'll use that later down the road, not today. But for our power supply build, I'm basically going to use this little section right, little tube unit right here. It's these are neat little devices. You can actually basically use a little screwdriver of some sorts like this, and you actually kind of unscrew one of these terminals, and then you would insert a wire such as one of these into that socket, and then you basically tighten that back down, and then you can see over here, hey, that connects you to pin 7 right there. So you actually have 2 connections per tube here on this thing. And that's how we're going to breadboard this thing out. And we'll use this little breadboard here for some of the capacitors that need to be in the power supply. For the purpose of today, I'm going to use electrolytics just to keep this thing small. I still haven't decided yet whether I'm going to try to put those electrolytics into the actual unit or not. But let me pause for a second. Okay, if everybody will remember, we were going to use this Classic Tone 40-18029 power supply transformer in our build. Nice, well-built transformer. Good chunk of iron here. And as you can see, it's got a multitude of wires. I've even tied some off already. Multitude of wires. But if you'll notice, it's kind of split up into 2 different sections here. you've got your inputs over here and you've got your outputs over here. And so what we're going to focus on right now are these inputs. This is the actual spec sheet from Magnetic Components, and what they've done here is you could use this transformer in a variety of scenarios. So if you lived in a country where your AC voltage was 100 volts, this is how you would wire it up. If you live in a country where, like the USA, where 120 volts is the standard AC wall outlet voltage, that's what you'd use, the 120. European, maybe it's 220, maybe it's 240. But this transformer has multiple variations on the input winding by having multiple taps on the input. Just like you could have multiple taps on the output of an output transformer to give you 4 ohms, 8 ohms, 16 ohms for your speakers. You can have multiple taps on the inputs of a transformer as well. So let's just pretend these 2 red dots right here are the, you basically tie it off of those and go into a wall outlet. So if you'll notice, you got a feed here off the black here, and you've also got this wire here that comes down that is the brown wire. Just like on this wire here, you're going to have brown white, as well as you're going to have this wire, right here, tied to it, which is the black white. And then you're not going to use the white or the gray wires at all. So if you'll notice what I've done here, this is the black wire and the brown wire, just like it said. Got the 2 ends tied together here. Just the same, you're going to have brown white and black white, just like it said here, tied together. And then there's a couple wires here that I've actually tied off. So the gray wire and the white wire here, we didn't need it all. So what I did was I used a little bit of heat shrink like this, took some snips, cut it off, put them over the ends once I cut the wire ends off, and then I used heat shrink tubing on the ends of these things like that, so that there's no way those wires come in contact with anything, because you would actually have some voltage here on this white wire and gray wire. And then there's also this orange wire in here, and I found out, if you look over here on their other spec sheet, I've kind of got it tied off now, but the orange wire here is their shield, and it's just kind of tied to the shield on the inside of this thing. So we'll actually end up grounding the orange wire, this wire right here, at some point in time when we get the chassis built. But for the bench work we're doing right now, no need for that. So that kind of gives us our inputs, and then what I've started going through right now is figuring out the outputs that we want to use on this amplifier. Okay, just thought I'd show you this. Back on the original Triodic design, this transformer that they had was 380 volts, center tap 380 volts. So 380, center tap 380 volts at 300 milliamps. Well, that's 760 volts from this point to this point right here, was the original design that Triodic had. And this transformer here that I'm looking at will only do 710 volts. And you may go, wow, that's 50 volts less. It's no big deal, trust me. This thing will operate just fine. You'll be able to bias it out. You may need to tweak these little resistors right here just a little bit to compensate for some of the drop if these voltages get too low. But all in all, this thing's going to work out just fine. But what you don't want to do is you don't want to use the, you notice this thing has multiple windings here on the high voltage. So you got the very furthest out, which would be red and red. So if you connected the 2 red wires here together, coming off of this transformer, then you would have 710 volts across those things. If you'll notice, the center tap here is known as red-yellow, and if you actually look at it, it's a little hard to see here, but you can see the yellow on this wire. So those are the 3 wires we're going to use for the high voltage on this thing. And if you see here, if you'll notice, the other wires here, which are red, green, red, white, and red, white, if you'll notice, these are other taps, red, white, red, green, red, white, that we're not going to use. And if you'll notice, I've tied all these ends off here. So, and what I'll end up doing is, just like those other ones, I'll end up kind of bundling these things up here like this, because we don't want to get rid of them. We want to keep them around, and we'll zip tie these things off. Now I'll probably do a little bit, I'll probably remove some of this wire when we put it in the actual amplifier, but for right now on the bench I'm going to zip tie those off just like that, and we can snip that off. So now we're down to, we know these are our 3 high voltage wire windings we want to use. Then we know we've got green, green, yellow, and green. So right here, green, green, yellow, and green. These are the ones we're going to use for the heater. So you've got actually you got 3.15 and 3.15 in a center tap, and if you go outer to outer you end up with 6.3 volts. And then you've got 2 more wires left here, which are the yellow wires here, and these make up your 5 volts at 3 amps. You can see right here. So that's all the wires coming out of this thing. Let me zoom out just a hair here. Whoa, get you seasick. Okay, 5 volt, 3 amp heater wires. Green wires here with the center tap are all for the 6.3 volts. There is your red 710 with center tap voltage. There is one lead of your AC 120 connection. There's the other lead of your AC 120, and we got that by putting these wires together just like it showed us on the input. And all the other wires now at this point we've tied off to the side and will not use for the purpose of building this thing here on the bench. Alright, I just thought I'd show you how these pins work. If you'll see, they're labeled here 1, 2, 3, 4, 5, 6, 7, 8. You have to get in really close here, but you can see it written down there on the board. And what I've got is I've got a meter set here on continuity. Touch these things together. And if you'll notice, each of these 2 pins here are kind of on the board. They're made together as jumpers. So in other words, if you touch this and this, no continuity, this and this, no continuity, but that and that. So the cool thing about that is for each pin, it kind of gives you an in and an out jumper to connect to. Okay, as you can see here, I'm starting to wire these things up. If you'll notice, I've snipped the wire off enough so that when it goes in here, there's really no metal sticking out, so there's no accidental things touching. And that's, about that long right there. Just a little bit of wire there. But this one will go into, and I got to lean over here, this will go into number 8 right here. So all we've done is taken the 2 yellow ones here into number 2 and number 8, coming off the 5 volt at 3 amps. And if you'll remember back over here, 5 volts at 3 amps were the 2 yellow wires here. The beauty, like I told you, now you've got a place you can come out of that, just like this, and connect over and get to your feed over to the breadboard or wherever else you're feeding next into the circuit here. Alright, I'm going to keep moving along here. Okay, so we've now got the 2 red ones wired up here, which was goes into number 4 and number 6, and those will be the plates of this 6U4 tube. And if you know the center tap, which is this red yellow here, remember back over here, red yellow here in the center, and that gives us 710 volts total. This becomes our new ground. If you'll notice here, it comes down. Becomes our new ground point here for the high voltage power supply at this point in time. So we're going to find a spot on this board over here, and we're going to snip this off yet again so it's not so long hanging out there, right along in there. And I think what I'm going to do is make this blue section right down here my new ground, and I'm going to end up having to move this transformer over just a little bit here. You can see, oops. You can see here what we got going on. We'll end up setting the transformer there. But this bottom row all the way across here will give me a nice ground. And I'm going to keep the high voltage up here on this side. The beauty of that is these things aren't close to each other. Remember in my other video I talked about, if you've been watching the parallel series I have to this, you can breadboard with some high voltage, and people will come back and say, no, you can't. I looked up the breadboard on Mauser and it says 30 volts max or 70 or 100 volts max. Well, that's pin to pin. That's side to side high voltage arc that you could handle between two of these points. If you were to use something here and then something over here, you really don't have that potential for arcing, and so no issues there. The only other thing you'd have to worry about is current draw through some of through this thing, and I think for what we're working with here, this will work out just fine. Okay, what I've done now is taken the green with the center tap of green yellow here, and I brought them over here, and the wires themselves are pretty good size because they're made for 5 amp. So they're too big to stick down in the breadboard, so I basically just used some wires I had here and extended them a little bit with some smaller gauge wire, and then I heat shrinked off where I soldered those on there. And we'll get ready to move this into the actual amplifier. I'll just cut these off here, but for the purpose now, I should be able to measure, you know, that I'm getting 6.3 volts across those two, and with a center tap here. This gauge wire here was perfectly fine at 300 milliamps. It was a lot smaller gauge wire, plugged right in. So that gives us our, let's see, our ground. Oh yeah, we still got to pull our positive off of pin 2 right here and come from it over into, I think I will feed this very top row up here. Let me see if I can find a jumper to do that with. Alright, if you'll notice here, coming off of pin 2 here of the cathode of this 5U4 is also where you pull the high voltage off, which we're then going to split into a rail here. For the purposes of this power supply build I'm doing today, I'm only going to do one leg of this. The other leg would be identical. And all I did was came off of pin 2 here, this other little socket. Remember, they were jumpered together. Fit over here, and I'm actually going to feed this into this very top row. So not the blue one up top, but this red one up top. So this will be my positive 450 volts. This right down here will be my negative. And the fact if I had used positive 450 volts here and then right beside of it ground, I'd have had an issue with this board arcing over in between those 2 points. But the fact I'm jumping way over here, no issues whatsoever. Okay, I decided to move these down here on this end, just get them out of the way, because we're really not going to use them other than measure them to show that we've got the voltage we need there. Really what we're doing is building this little power supply ladder section here at this point. So let's grab some 33 microfarad, a 33, a 22, a 10, and these resistors and one of these 10 Henry chokes here. Okay, up next I want to show you this. This is something I made at least 20 years ago. One end is just a 2-prong power cord. The other end comes down here, and it's kind of soldered and then heat shrunk onto a set of alligator leads here, as you can see. So this will end up actually plugging into the Variac, but I just want to show you here. I'm going to clamp these things on there, on top of these things, really good like that, and push that rubber up there, but I still don't trust it. Just you know, having 110 floating around here on the bench with an exposed little section like that, really scary. I don't want to be a part of it. So for safety's sake, and just something temporary, because we can undo this, and then you know, when we get ready to build the actual amplifier and the chassis, just something like this to actually take that thing up, so that I know I'm not going to get shocked. And I'll do the exact same thing here with the other lead as well. It's you want a good connection, but that's just scary to have floating out there. Alright, not only did I tape them up, but I also taped them together so that they're not all floating around floppy loose. But you can just kind of move that out of the way, and then we'll feed, like I said, we'll feed this across into the Variac. But hey, we went and found, let me zoom in here on this, went and found our 33 microfarad 450 volt capacitor we're going to need. Went and found our 22 microfarad at 450 volts we're going to need here. And we found our, let's see, 10 microfarad at 400 volts that we're going to need here. And we're going to get these things wired up here in this board, and I'll show you what I did. Okay, as you can see, I took and used a little drill gun. By the way, this little Ryobi unit is amazing. It's Tech 4. Get a spare battery and great little drill drivers. But went ahead and mounted that down. I didn't want it flopping all over the place. I would mount the transformer down back here if I had room, but what we're going to do is take this thing and kind of jumper it off here, and I'm going to have to twist that in a little bit. Okay, I'd like to apologize. Here at 20 minutes into this video, I'm going to remake the latter part of this. I posted this video last weekend, and I actually had an error in it. And my error consisted of, and it's pretty easy to see right here, this little jumper. Totally forgot that these breadboards stop halfway through, and you've got a jumper to the other side here for either the red or the blue, and the same on the top section. So I've been working with the breadboards on my the little box setup I showed you earlier. They don't have that scenario, so but when I was working with these, they did. And so I had some components over here on this side, trying to tie from that to ground, and since they weren't actually being grounded because that jumper wasn't there, they were kind of floating high in the air and never really giving the results I was after. So and one other error I had, I totally omitted a 33 microfarad capacitor. So you come off of the pin 2 here of the 5U4, and you come over, and before you actually go into the 10 Henry inductor, there is this 33 microfarad capacitor right here, and I had omitted it. So if you kind of compare what I've got here, you've got a 33 microfarad, then you've got the 10 Henry inductor, then another 33, then this 8.2 k ohm resistor, then the 22, then this 10 k resistor, and then the 10. And if you'll see what I've actually put together here, you'll notice I'm tagging all of the bottoms here of these into the blue row, which I have hooked to the center tap of the transformer on the high voltage output winding. If you notice the center tap right here ties over, and that's ground at that point. And what I've done with the positive sides, one I've hooked here before you ever go into coming off of the power supply hot lead here. You'll notice it comes right out of pin 2 here of the 5U4. I'm jumpering across and back to ground, so that's the first 33. And then I go through the inductor here, out the other side of the inductor, down to this point right here. And from that I'm jumpering over here with the other 33 to ground. Then I go through the 8.2K here, you see, and then I'm tagging over to ground here. And then you come back over here with the 10K, and there's the 10 microfarad. And I'm using 450 volt caps here. They probably should be 630, but I've been being very careful with the Variac not to take this thing over 450 volts. And I really don't have a load on this thing to speak of, so I think we'll be fine here on the lab bench. Let's get this thing some leads hooked up to it and powered up, and I'll actually show you what's going on. Okay, let me point out what I've got going on here. First and foremost, this meter here is tied between this point right here and right here. So that point is actually right here where the 450, it's right on the other side of this 10 Henry inductor, as you can see right there. This red lead here is actually tied between the 8.2K and the 10 ohm, and the other side of it's coming over here to ground. So if you pay attention here, you should have about 350 volts right there. And then this point over here on the end would be about where 300 volts would be at. And interestingly, you see something new I've added here that didn't exist before. This is a 22 k ohm resistor. That's actually the load I'm putting across this power supply, and I'll explain that more to you in a little bit. Right now it's just a load I'm using to, otherwise this power supply has no load, and thus there's no voltage drop across these resistors. Okay, a couple things you may note here. You notice there's a teeny bit of voltage here and a teeny bit of voltage here, and then this thing's not turned on. Well, why is that? Well, it's because I was testing a while ago, and I actually had, these capacitors might have still the slightest bit of charge left in them, So if you wonder what this green lead hooks to, if you remember in one of my videos earlier, I made a basically a decharging wand which has a resistor built in here, and you just use that to kind of touch across. And if you'll notice, once I do that, these things start shorting down to kind of to 0 volts here. Interestingly, each one of these has a charge, and if I decharge one, one of the others will start charging it back slightly. I mean, they're just, you know, it's really small voltage, but it's interesting to watch nonetheless. So let's go ahead and apply some voltage here, and you'll watch these things climb up quickly. All right, we're at 400 and let's get that thing. I'll turn the variac just a little bit. All right, we're hovering right there at 450 volts here. On this one, if you'll notice, this one has about 355 volts. It says 350 here. I'm going to explain why this may not be exactly accurate. Let me turn this off a second and use my decharging wand here. As you can see, get a tad bit, a little spark there when I do that. And let's discharge this one. And let's discharge this one a little bit. Okay, not much left over on there. I want to move that over here, and I want you to see this. Turn it back on. And if you'll notice, I'm hovering around 243 volts, 244 volts here. Yet the schematic says there should be about 300 volts right here. I want to explain to you why that is. But at least you can see the power supply kind of working. If you kind of overlaid, let me turn this off, I don't want to accidentally touch something. And let me discharge it real quick. Okay, let me move this stuff out of the way. Alright, if you'll notice here, coming off the 450 volts, you would have the primary here of this output transformer, which it says is 5 to 6K, but that's output impedance. That is not output resistance. In other words, you want to go find out what the DC resistance of this output transformer is, and I looked it up. It's about 262 ohms here on the spec sheet. And then you'd actually be flowing through this tube. You'd also have this 390 ohm resistor right here, plus, you know, a little bit of what's in parallel with this thing on each side. Similarly, coming off the 350 volt stage right here, you would have this SRRP stack, which would have a 1K resistor, another 1K resistor. And then you would also, coming off the 300 volt tap out here, you would have this 47K ohm resistor coming through this tube. You would have a 1.5K here. So you basically have to do some pretty in-depth circuit analysis to figure out what the load is across this whole thing. Well, I can tell you sorta-ish kind of 22K ohms as a whole, but individually between each of these stages you would have a load between there and ground, and between here and ground, and between here and ground when you built the rest of this circuit and inserted it in there, as you can see here. And that's a little too complex to actually try to build out here on this breadboard and or calculate for this video. So that's why you know, we kind of had the 450 volts here, the 350 here, and then we were slightly off here on the 300 volts. We just didn't have this DC resistance calculated perfectly. But it really doesn't matter, because Dick figured all that out as he designed this this amplifier. And as we hook the second stage to this, which will be the preamp and the output tube, all that'll get solved for him. And I got meters over here beeping at me that I'm leaving them on too long. So we'll turn those off. I do want to take you over and show you one neat thing before we close this video out. But you kind of get the gist of, we built the power supply here. We simulated a load here, but you'd actually have to calculate the load for each stage and insert it parallel all along the way if you wanted to have this thing exact. But I think this is close enough for what we're doing here in this video. Okay, this is a piece of software I use from time to time. It's pretty neat software, and it's absolutely free. It's from Duncan Amplification, so if you just kind of search for Duncan PSU Designer 2, which stands for Power Supply Designer, it'll take you to this. And then when you get there, you'll have to learn how to change component values. Let me give you an example. This right here is D1 5U4GB, but I could click on that and I could change that to say a 5Y3 or one of many different types of rectifiers, and it'll typically have a capacitor and maybe a load, and maybe a resistor, and some of them you'll have to delete little sections. Some of them you'll have to change the values here, like 33U for 33 microfarad. I inserted this inductor here at 10 henries, and then I went and looked up the 158M and found out that it had a DC resistance of 262 ohms. And then that's the 8.2K resistor that we've got in the power supply, the 10K resistor. So basically, I built the power supply here using their little software. Like if you wanted to insert another section, you could click here and insert and tell it to add another RC filter, and it would add another section there. And I'm going to go ahead and delete that, but take it back. And if you'll notice then, I've also clicked on, I've ran simulate, and it actually simulates this circuit. It's a variation of a SPICE modeling tool. But if you'll notice, I'm measuring voltage here at C1, which is right here across this resistor, which is about where we should have 450 volts. And if you'll notice the difference between C1 and C2, C1 would be before the inductor and C2 would be after the inductor. If you notice the red, all the little ripple on it right here, and then after the inductor, the green, which would be C2 here. See if I click that off, you just see the green. But you can see the difference between the two. And then here, voltage at C3, which would be right here across the 22 microfarad, you're down here in the 350 volt range. And then if you measure here, C4 here, the voltage across that, if you'll notice, you're down here in the 240 some volt range, which is exactly what I had that we built on the bench. Yay! So the simulation and the bench match up perfectly. The problem is you would have to be able to simulate a load in between each of these sections to actually get it perfectly right, as it would be in the final amplifier build. But this gets you close enough. Pretty cool. You can click on here, you can tell how much current's going through something, maybe the voltage drop across something like R3. Well, if you notice, I clicked on that and it turned white. It's the exact same voltage as measuring across the capacitor, because these 2 points are totally in parallel right here. But that's kind of how we got this thing designed, and it's how I kind of proved out that what was on the bench was right. And by the way, that's how I came up with the 22K ohm resistor load. I started out by saying that if you remember, it had a 47K ohm which resistor across one of those loads, and I thought, wow, that's a little high. And I just sat here and played with it until I got this thing down to about the right voltage for this secondary, and then I kind of compared it to the sheet, and lo and behold, they match up. Just not going to get it perfect without throwing a load across each section of the capacitor. And unfortunately, this software only lets you put one load on the power supply, not one load per section. But it's a great piece of software. You can also use it for solid state. I could change this whole section right here. If I said, hey, I don't want to do a bridge, I want to do a maybe a half wave instead of a full wave. Well, then you would see what would happen. I'm only using half of the tube at that point. You'll notice I've got more ripple here and probably more ripple on all these sections as well. If I want to change it to a full wave, if you'll notice, then all of a sudden we're back to where we were. If you want to change that to a bridge, you'd lose some voltage, but you'd end up using two 5U4s there, kind of in a bridge mode, to make that work. But it's pretty cool. You can play around with your you can play around with changing, hey, if I change that 8.2 ohm to say 12K ohms, what would happen? You can see it drops this voltage but doesn't affect this one that much. Pretty cool piece of software. I thought you'd get a kick out of. I'll tell you what, next build, what we're going to do is actually wire this thing up to the preamp itself, and light that thing up, and then we'll have the whole amp built on the bench and running at that point in time. And then beyond that, it'll be actually build this thing and put it into the chassis and get this thing done. I will tell you, I've got some travel coming up over the next couple weekends for work, where I'm flying out on Sunday about 3 weeks in a row. So if I can, hopefully I can get to some videos on Saturdays. If not, it could be a couple weeks till I get back to this. Thanks for watching, everybody. Sorry for having to redo this. There were about 300 of you that watched part 7 with my mistakes in it, and we fixed it. So if you rewatch this, I'll give you an indicator to just start it at 20 minutes into it. Thanks again, everyone.